In this lesson, we will focus on how to find the domain of a function. We will start with the main concept behind determining a function's domain. Then we will work through various examples, including polynomial functions, rational functions, radical functions, and functions involving fractions with radicals. When working with real numbers, there are two rules we must never break. Firstly, we cannot divide by zero. Division by zero is undefined. Remember this rule when finding the domain of a function with a variable in the denominator. Secondly, we cannot take the square root of a negative number. The square root of a negative number is undefined in the real number system. Remember this rule when finding the domain of a function with a variable under a square root. The domain of a function consists of all possible values of x for which the function is defined. In other words, it is the set of all values of x that you can plug into a function without breaking these rules. Keep this in mind as we proceed. Polynomial functions do not have a variable in the denominator or under a square root. So, we do not need to worry about dividing by zero or taking the square root of a negative number. Therefore, polynomial functions are defined for all values of x, which means their domain is all real numbers. In interval notation, this is written as, in parentheses, negative infinity, positive infinity. You can write the domain in either of these ways. They mean the same thing. Now, let's move on to finding the domain of rational functions. Unlike polynomial functions, rational functions do have a variable in the denominator. Therefore, for a rational function to be defined, the denominator must not equal zero, as division by zero is undefined. To find the domain of a rational function, set the denominator not equal to zero and solve the resulting inequality. The solution to the inequality represents the domain of the function. For this function to be defined, x minus 7 must not equal 0. Now, solving this inequality, we find that x cannot equal 7, right? Therefore, the domain of this rational function is all real numbers except 7. To write the domain in interval notation, first represent it on a number line. A number line helps to clearly visualize which numbers are included and excluded from the domain. Mark an open circle at 7. This indicates that 7 is excluded from the domain. Then, shade the line to the left and right of 7. This indicates that all other real numbers are included in the domain. Now, from this, you can easily write the domain in interval notation as negative infinity to 7 union 7 to positive infinity. The parentheses around 7 indicate that 7 is excluded from the domain. Note that parentheses are also used for negative and positive infinity because they do not represent a specific point on a number line. For this function to be defined, x squared minus 16 must not equal 0.